some questions on motion. But before I start, I would like to do a quick introduction about motion. Although I may not be really explicit on what I'll be saying, since this video is majorly for solving of problems, but I'll try as much as possible to make everything I'll be saying understandable. Now, if we say motion, what we're doing is physics. I will be treating motion. What is motion? Motion otherwise can be said to be movement. Motion is simply the change in position of an object from one place to another. If I say an object and a body, they are being used interchangeably in physics. If I say an object or I say a body, then it can be anything. It can be you, it can be your toy, anything whatsoever. So physics generally interprets objects and a body as anything, so far it's a matter. Now, the change in position of an object from one place to another, that is, if you are at a particular point, let's say the point is point A. Now there's another point, the point is point B. Before somebody that is found at point A, or an object that is found at point A, before you can find that same object or that body at point B, then the body must have undergone motion. The path of motion where the person now takes, it varies. The person might decide to go directly to B. The person might decide to walk in a bent way. And the person might decide to walk in a zigzag way. But regardless of how the person moves, the person has actually moved from point A to point what? To point B. Then whenever this happens, you say motion has occurred. Movement has occurred. So I won't waste much of our time. There are a lot of things associated with motion. Firstly, before motion can take place, there must be velocity. Motion will take place when there is what? When there is a change in velocity of an object from one position to another. That is, presently where you are at point A, you possess a velocity. This velocity that you possess presently, that is your initial velocity, is the velocity that you possess from the point where you want to move from, and by the time you get to the place you are going to, you possess another velocity which we know as the final velocity. And don't forget, going to this B, this A is a frame where we are coming from. This kind of frame is known as frame of reference. That is, referencing A, I'm going to what? I'm going to B. So this A is our frame of reference. So when you move from point A, you have an initial velocity. And when you get to point B, you have a final velocity. So I believe we get that. Now, one of the things that is also associated to motion is acceleration. What is acceleration? Acceleration is simply the change in velocity with respect to time. That is, how is your velocity changing with respect to time? If I say change in velocity does not necessarily mean you have increased your velocity. There are times whereby you decrease the velocity because, let's say for instance, I've been moving from a point before I got to point A, I was moving before. Now, my plan is to stop at point B. This kind of situation, there's probability that from that point I'm coming from, I've been increasing my velocity with respect to time. Therefore, it can be said that I've accelerated. Let's say the point I'm coming from is point O. Coming from point O, I've moved to point A, I have accelerated. But point A is not where I'm going. I'm actually heading to point B. Now, what will happen at point B? I will definitely stop at point B. Now, if I plan to stop at point B, then I don't have to increase my velocity over the time range from A to B, because if I do, I will actually not stop at B. It's just like somebody that is running and you're already getting closer to the place you're supposed to stop, and that is when you now increase your speed, because speed is actually like velocity. Just as speed is a scalar quantity and velocity is a vector quantity, that is, vector quantity in the sense that it has both magnitude and direction, but speed does not have direction, it only has magnitude. So imagine somebody running a race and you are about to get to where you're supposed to stop, but you now increase your speed. That is when you now decide to, oh, let me run faster. Will you ever stop at the stopping point? No, that won't be possible. Which implies that for you to stop, you need to decrease your what? Decrease your speed. Now, if you decrease your speed, that is, if you decrease your velocity, what is happening there is also a change in velocity, but it's a decrement, not an increment this time around. Don't forget I said that an increment in velocity with respect to time will give us acceleration. Now, but if it is a decrement in velocity with respect to time, that will give us deceleration. Deceleration is simply the opposite of acceleration. That is, if I'm not accelerating, then I'm what? I'm decelerating. So we have to take note of these two things. In one of the questions we'll be solving, we will be making use of acceleration and deceleration. I've also mentioned initial velocity. There are some times that when we're solving questions, we come through some things, some terms that is used in motion. For instance, they might say a body is at rest. What does it mean to be at rest? Rest is an English word that almost everybody will know. If peradventure I say I want to go and rest now, then I will be at a position whereby I'm not engaging myself in anything. So if we are talking about motion, if somebody is at rest in motion, motion is the action here, but somebody is at rest in motion, definitely that means that the person is not under motion. The person is not what? The person is not moving. So whenever they say somebody is at rest, the person is not moving, no motion. And don't forget I said for motion to occur, there must be change in velocity. So this implies that if the person is at rest and there is no motion, this implies that the person possesses zero velocity. The person has not moved. The person has not been given any velocity. So the person has what? Zero velocity. And don't forget what I said the other time about frame of reference. So if my A is my frame of reference, that is, I'm moving from A to B, then my initial velocity at A, if I was at rest here, my initial velocity here will be zero. But let me go back here. Let's say this was my frame of reference. I'm coming from point O. I'm going to B. And I decided not to stop at all at any junction until I get to B. Now, moving from point O, I'll pass through A. But when I got to A, I had to start decreasing my velocity and no longer increasing the velocity. So I increased the velocity from point O to point A and I accelerated. But from point A, I decreased my velocity from point A to point B. That gave me deceleration, or what is otherwise known as retardation. Now, look at what is happening here. If I split this motion, I didn't stop at all. All I did was decrease my velocity. So if I split this motion from O to B, if I split it into two parts, O to A and A to B, you will realize that the initial velocity in this place, because I was actually at rest from this frame of reference, the initial velocity in this case will be 0 meter per seconds. That's the initial velocity there. But let's say when I got to this place, my velocity was actually, I've increased from 0 meter per seconds to 5 meter per seconds. Now, with respect to this last part of the journey from A to B, this 5 meter per seconds will be my initial velocity. So this is telling us that for different stages of motion, you can have different initial velocities. So for this beginning, where I was starting at rest, my initial velocity is 0. But for this stage, for this completing part, the A to B part, my initial velocity is 5 meter per seconds. Of course, let's say by the time I was going to end the whole thing, don't forget I said I was decreasing my velocity from 5 meter per seconds. Let's say I ended at I stopped at B. So if I stop at B, automatically I've stopped again. What happens to motion? No motion is occurring again. Then definitely my velocity here also, which will be my final velocity. In physics, we mostly represent initial velocity with U. Initial velocity with U. So my final velocity for the whole journey will now be 0 meter per what? Seconds. Why is that so? Reason being that I started from rest, I increased my velocity, and later I started decreasing my velocity until I exhausted all the velocity that I've gotten. So I now stopped again at B. Stopping again at B means that I rested at B. in the process of moving. So the initial velocity for the entire journey and the final velocity for the entire journey is 0 meter per what? 0 meter per seconds. So that's the concept of velocity changing. And let me quickly say more about this. Let's say for instance, as I was moving from point O, still 0 meter per seconds. This is my point O. My U is 0 meter per seconds. Let's say I move to point A, and my velocity still 5 meter per seconds. But I didn't decide to stop at point B. I decided to stop at another point, let's say point C. But before I got to point C, I kept increasing my velocity. Let's say before getting to point B, I've increased my velocity again. Let's say my velocity now is 7 meter per seconds at point B. We don't have to bother about where I'm going. So what I just want to put into place is that in this previous situation, our initial velocity is 0 meter per seconds, and the final velocity for the first stage of the motion is 5 meter per second. But mind you, the final velocity for the first stage of the motion is the initial velocity for the next stage of the motion. It's just like where you ended this, you continued from it. So the end of a session is the beginning of another session. So looking at this now, when this decelerated to 0, instead this journey I moved from 0 to 5 meter per second. I've increased my velocity, I've accelerated from 5 again to 7 meter per second. I've also accelerated because I've increased my velocity over time. So these are the kind of things we can be experiencing under motion. Now, having said all this, let's quickly go into problem solving. Of course, there will still be a video that will give the subject on motion. I will give it in detail. So I will ask you to watch out for the video. So proceeding to the question I will have here. The question we have here might be a challenging one, but be rest assured, everything will be crystal clear by the end of the question. Now, the question says that a body at rest, that is, there's a body at rest. Whenever you're solving a physics question, you must always have, as you're reading the question, you must interpret something at the back of your mind. Those terms that are being mentioned in the question, you should take note of those terms. Now, this question says a body at rest, which means that this body has an initial velocity of 0 meter per second. That's where the body is starting from. Now, because the body was given an initial uniform acceleration. Now, another thing that I didn't mention the other time when I was introducing motion is uniform acceleration. There's acceleration, yes, but there's also uniform acceleration. What does uniform acceleration mean? Most of these things are English words. Uniform, that is the same. When we have the rate of change of velocity over a particular time interval, if this rate is the same, that is, let's say I change from 3 to 6 in 2 seconds, then if I'm changing from 6 to 9, I should also use 2 seconds. If I'm changing from 9 to 12, I should also use 2 seconds. That's what this is all about. So let's say for instance, if I want to consider my uniform acceleration in the case I just illustrated now, if I'm moving from, let's say not 3 to 6 now, let's say I'm moving from 3 to 9, then definitely I'll be using how many seconds? That will be 4 seconds. So if you have such a change of velocity with time, that is equal change in velocity at equal time interval, then you have a uniform acceleration. Don't worry, most of the questions you'll be facing in WAEC, JAM and the likes, they will all be on uniformly accelerated motion. Even our projectile, which is not a uniformly accelerated motion, it is being modeled to be a uniformly accelerated motion. So let's continue with the question. So the question says that the initial velocity is 0 meter per second, that is a body at rest, was given an initial uniform acceleration of 8 meter per second squared. So the body started with an acceleration of 8 meter per second squared. Now, we have the initial velocity, we have the acceleration. thing, there's nothing like final velocity here. You know, since they say it's accelerated for 8 meters per second squared, then from this initial velocity there must have been a final velocity, because it said a body at rest was given an initial uniform acceleration of 8 meters per second for 30 seconds. For 30 seconds. For 30 seconds is implying that he started the journey at a point and he ended the journey at a point. That was after 30 seconds. So at that 30 seconds, he must have attained a final velocity for this stage of motion. Now, how do we now get this final velocity? We can actually compute that. Now, there are 4 equations that I would like you to be conversant with. I will write them out now. I'll be using them as I'm solving questions. These 4 equations, they are called equations of uniformly accelerated motion. Mind you, quote that word, uniformly accelerated motion. If the motion is not uniformly accelerated, forget about it. You cannot use these equations. So I will write the equations here. The first one, which is very, very trivial, is the case of V equals U plus AT. I've already highlighted what we are using for. V is our final velocity, U is the initial velocity, A is the acceleration, and T is the time. So anywhere you see T, you know that's time. Anywhere you see A, that's the acceleration. And when you see U, we have our initial velocity. When you see V, we have our final velocity. Now, another one is V squared equals U squared plus 2AS. Now, this is the second one. Now, this is V, also already we know that's our final velocity. And this is U, that's our initial velocity, acceleration. But we have a new parameter here, S. This S is signifying displacement. It's signifying distance. Mind you again, in this, whenever we are dealing with uniformly accelerated motion, I can use speed and velocity interchangeably. I can use displacement and distance interchangeably. Although these two phenomena, they are not the same thing. Displacement is vector while distance is scalar. Velocity is vector while speed is scalar. But the reason why I'm able to use them interchangeably in a uniformly accelerated motion is because by the time you consider both of them, they will take the same form. They will take the same path. There will be no difference between the two of them. So I can use them interchangeably. So let's proceed to the third one. Now the third one is S equals UT plus half AT squared. That's the third equation of uniformly accelerated motion. And the fourth one is S equals U plus V over 2 times T. Now, these are the 4 equations of a uniformly accelerated motion. I'm telling you, if you have any uniformly accelerated motion that you want to solve a question on it, these 4 equations are more than enough to be able to take care of them for you. It's just dependent on how you can use the 4 equations to be able to solve problems on your own. Now, if you notice very well, for these first 3, acceleration is present there, and this one, acceleration is not present. So there are cases whereby you have time, you have one of the velocities, and you have the distance covered, and you're looking for the other velocity. So in this case, you can just employ this equation. There are cases whereby you don't need the final velocity, you only need the initial velocity, you need the distance, and you need the acceleration. Probably you're looking for the time. So different cases, you can make use of different equations. So before we proceed, even though the question, we have not gotten to what the question wants us to do first, but because I talked about initial velocity the other time, and I also talked about final velocity. So let's try and see, maybe we can get something out from this place. So we have U 0 meter per second, we have A 8 meter per second squared. So from the question, we are given time. So let's see, the time is 30 seconds. Now let's see if we can get our final velocity from this place. Of course, we can get our final velocity from this place. Let's look at our equation of motion. We have U. Yeah, if you look at the first one, we have U there. We have A. Yes, A is also present in the first equation. And we also have T. T is present there. The only thing that we don't have there and that is present here is our V. In fact, that's sufficient enough to find my V, because I know every other thing here, given here, It's only v that I don't know. Then one equation is sufficient enough to be able to solve for one unknown. So what will I have here? So my v, which is my final velocity for the motion, for the stage of motion whereby you were given acceleration to be 8 meters per second squared. For that 30 seconds, what will be our final velocity? So our final velocity will be v equals u plus 80. My u is 0, then plus a is 8, then t is 30 seconds. 30. So definitely my v, since this is 0, my v will automatically be 8 times 30, which is going to be 240 meters per second. So that's my final velocity for that stage. Now, one thing I would like us to do is, I would like us to run through the question so that we know what exactly we are doing in this case. I need some things here. Most of these things I have done here, they are irrelevant as far as the question that we are being asked is concerned. Now, the question says a body at rest was given an initial uniform acceleration of 8 meters per second squared for 30 seconds, after which the acceleration was reduced to 5 meters per second squared for the next 20 seconds. The body maintains the speed attained for 60 seconds, after which it was brought to rest in 20 seconds. The question wants us to sketch the velocity time graph of the motion. That's a very, very important thing. The question wants us to find the maximum speed, find the average retardation, and also find the total distance covered throughout the journey. Now, from the first thing that the question wants me to do, the question wants me to sketch a velocity time graph. And if I want to sketch a velocity time graph, don't forget velocity is a term that we use in motion. Time also is needed in motion. So I want to sketch a graph, but the graph is titled velocity time graph, which implies that my graph will look